What's up everybody? In this video, we are going to upload code from Tinkercad to the Arduino. Tinkercad is great because you can work and test your circuits and easily share it with me for troubleshooting. However, there are some things that Tinkercad cannot replicate, and building circuits is a lot more fun. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup sketch. Hover over the circuit and right-click Tinker This to open the sketch in a new tab. Next, hover over the LED-code on/off circuit and left-click Tinker This. In the LED-code on/off sketch, click on the Code tab. You will see the code that we wrote for the blink sketch. We do not have any comments or serial.println statements. Before we upload our code to the Arduino, let's add these so we can see how the code executes. Select the basic setup sketch in the Other Browser tab and click on the Code tab. Cut and paste the multi-line and single-line comments before the setup function into your LED-code on/off sketch. Let's add some information about our sketch. Under Program Name, put LED-code on/off. For the version, put 1.0. Put your name as the creator. Last, for the description, add sample code to blink an LED. Next, cut and paste the comments and serial.println statements from the setup function in the basic setup sketch into the setup function of the LED-code on/off sketch. Cut and paste the serial.println statements in the loop function from the basic setup sketch into the loop function in the LED-code on/off sketch. Uncomment these so it will print when the code is executing the start and end of the loop. I'm going to add one other thing that will help us see how our code executes through the loop. Each time I turn on or off the LED, I'm going to add a serial.println statement. So when the LED turns on, the serial monitor should say LED on. And when the LED turns off, the serial monitor will say LED off. We are now ready to upload our code to the Arduino. Click on the Code tab and then click on the Download Code button. You will see that your web browser has downloaded a copy of the sketch we wrote in Tinkercad. The file has the extension .ini. Open the file in the Arduino IDE. You will get a message asking to create a folder for the sketch. Each time you create a new Arduino sketch and save it, the Arduino IDE creates a folder to hold your sketch. The folder and file name need to match. You can create new tabs in your code, and the IDE will store each tab as a separate file in the folder. The interface of the IDE is pretty straightforward. The main area is for your code. Along the top of the menu, there is a button to verify or check your code for errors, a button to upload the code to the Arduino, a button to debug, and an option to select what board you are using. The left-hand column has a button to your Arduino sketches folder, normally in your documents, a button that manages your microcontroller boards, a button for libraries, a debug button, and a search button. On the far right side, there are serial plotter and serial monitor buttons. Below the code window, you will see an output window. This will show you any messages as you upload your sketches to your Arduino or install any libraries. Next, plug your Arduino into your computer via the USB. The Arduino should not be wired to the breadboard yet. The Arduino IDE can be used to program for many different microcontrollers. You can also have multiple microcontrollers plugged into your computer. We need to ensure that we are telling the IDE to communicate with the correct type of microcontroller and identify which port the microcontroller is connected to. To select the microcontroller, click the Select Board area in the IDE. You should see your Arduino Uno R4 Wi-Fi listed. You will see a name below the Arduino that says something like /dev/cu.usb modem and some letters and numbers. This is the address of your Arduino on your computer. The name will be different if you're on a Mac or PC. Great, unplug your Arduino. As you continue to explore physical computing, you may use different boards. It's important that you select the board that matches the one you are using. Now we will build our circuit, copying the diagram from Tinkercad. Start off by connecting a red wire from 5 volts on the Arduino to plus on the breadboard. Next, connect GND from the Arduino to minus on your breadboard. Connect the plus rails on either side and the minus rails on either side. Next, we will add the LED. Remember, electrons in an LED only flow in one direction. An LED has a cathode that connects to ground and an anode that connects to power. Plug the LED into 2 different terminals in the breadboard. The cathode side has a flat edge on the side of the LED. If you run your fingernail over the edge, you should be able to feel the cathode side. Connect a black wire from the cathode end of the LED to the minus rail. Next, we will add a resistor to the breadboard. It doesn't matter which direction you place the resistor in the breadboard. Assure that you have a 220 ohm resistor. Resistors are color-coded based on their resistance. The 4 bands on the 220 ohm resistor should read red, red, brown, gold. Put one end of the resistor in the same terminal strip as the anode of the LED, and the other end of the resistor in a new terminal strip. We will complete our circuit by connecting a wire from the resistor to the Arduino pin. Put one end of the wire in the same terminal strip as the resistor, and the other end in the pin identified in your code. In my code, it is pin 2. Great! We now have a completed circuit. Before we plug in the Arduino, it is important to double check our wiring. Remember, electrons move fast, and if you have a short circuit, it can harm your components. Plug in your Arduino and ensure it is selected as your board. Click the arrow to upload your code. You should see the LED blinking on your breadboard. Next, click on the serial monitor button. You should see information being printed to the serial monitor as your code executes on the Arduino. In the serial monitor, you will see 9600 baud. This is the speed of the serial communication. It should match the rate in your serial.begin statement in your setup function. It is important that you match the baud rate in your code to the baud rate in the serial monitor. This will ensure that you can properly view any communication to the serial monitor. To recap, at the end of this video, you should have a better understanding of the Arduino IDE, how to upload a sketch, and use the serial monitor.